All right, hello everybody. Today is the 7th of March, 2023. We're approaching that daylight savings time here in Dallas in spring. This is the Dallas Personal Robotics Group, Builders Night Virtual. And we're just going to do the usual thing which we usually do. And that is we're going to go around the table and talk about largely robot-y things or things adjacent to robots. So software build. Talk about progress on robots and ask questions for the group. And we have a queue started up, so it will be tonight Ray, Pat, Ted, Mike, Doug will go, and when Kareem comes on, and then I'll go sometime as well. Having said that, so let's dive right in. So Ray, what do you got?
Okay, you can probably just pin me and I can show you. Got another one of these from the Goodwill. Ooh. It's a different brand, but it looks like the same connections are on the motor. You know, the three phases, the three Hall effects, and it looks like a tachometer output, and the wheels look the same size. The drive board inside is different in the two. Let's see whose brand is this. This is a Jetson. The other one was an actual hoverboard. They both weigh a ton. This one actually runs on 36 volts. The other one ran on 25.2 volts. So a little bit, well, definitely higher voltage. Only 2.5 amp hours for the battery rating. And this battery was, I haven't tried to charge it up, but it's supposed to be a 36 volt battery, and it's sitting around about 15 or so. So it may not be any good anymore. But that's okay. I really wanted it for the wheels. So I'm thinking one or two manufacturers make the wheels, and they've all kind of decided on what they want in their wheels. You know, the three Hall effect outputs, the tach output, the three-phase inputs. So they all seem very similar. I didn't hook this guy up yet to see, how fast the wheels were. The speed on this one is higher. I think it says it'll do up to 10 miles an hour. I think the other one was only 7. Yeah. Max speed 10 miles per hour, same max weight limit, 220 pounds. It looks like this one, some of the screws, or I don't know what you refer to them as. They're like the little circular column that the screws into. Actually broke off. You can see a little white piece there at the bottom of that one. So I think maybe the design of this one, the plastics is lacking a little bit. But anyway, so that was one thing. The other thing that I saw was I'm going to present here, share. This was an upcoming events from ST. They're doing, sessions in the United States. This is for the STM 32C0. I think they're kind of saying it's, a replacement for an 8-bit processor. It's a 32-bit processor. Anyway, the online workshop days are, Dallas or Frisco is Friday, March 24th, if anybody wants to do that one. This time, they're not giving the board out for free. They will give you free shipping, but the board actually costs you $10.10. So, and there it is there, Nucleo C031C6. Shipping, they knocked off about $6 for shipping. And they say you have to have the board, before you go to the thing. They had, let's see if I can find where that is. Nope. Anyway, it kind of looks like low-level stuff that they're trying to do, blink an LED, get PWM working. So I'm assuming they're probably going to download the latest version of, the STM32, the IDE, and I'm not certain what the latest revision is called. I don't know if it has, MX Cube in it. I'm assuming it does. But I actually haven't loaded that stuff on this laptop yet. I have it on my older laptop, and haven't used it in a while. Anyway, so that was another thing. And let's see, where is it? Oh, yeah. My tank is supposed to be here by tomorrow. And that's part of a new strategy with 6-can and can. So it's a 1 gallon, basically compressed air tank with 4 ports on it. Anyway, I think that is all I have. So,
how much did you get the hoverboard for?
What's that?
How much did you get the hoverboard for? The other one was $3 or something.
Oh yeah, no, the first one was $6.99. This one was a little higher priced, $8.99.
Oh,
but,
that's good.
So, yeah, it looks like I said, they're different manufacturers. The motors have the same connections on them.
So where are you finding these great deals?
Say that again.
Where are you finding these great deals?
Oh, the thrift store. Let's see, it's just south of McKinney and 380. I think it's called Thrift Plaza in McKinney, Texas. So, but that seems to be, I don't know, for me anyway, I find the most stuff there. There's another one in McKinney. I think it's on Graves, just north of 380, and that one used to have all kinds of computer stuff, but and they actually built a little kind of walls that didn't go all the way up to the ceiling. With the set of doors that could lock, and they had all the computer stuff in there, and then the walls disappeared, and so did all the computer equipment. They said it's in Sherman now or something. So, and that's a little too far to go to look at junk, I guess. So, but so I don't know how they do it, but as far as distribution, when stuff comes in, if one of them's designated to get all the computer stuff, but I haven't seen a computer in that other one in a while. No laptops, no Nooks or anything like that. So, but yeah, so the one, and it's it's like the stuff is distributed all over the place. They have, like, I don't know, I'd say mainly clothes, but on top of the clothes racks, there are a bunch of trays. And for some reason, they started distributing like the kids' toys and stuff like that. So it's not in one area anymore. So you have to wander and kind of look on all the tops of these clothes racks now to find, the buried treasure. So it's makes you work a little harder to find it. But anyway, I've found some good things there. So.
Well, cool.
Okay.
Those might get incorporated into an outdoor robot. I don't know. So,
Ray, could you post the registration page for that thing so we get it in the minutes?
Registry. Oh, for the
The
STM stuff?
STM32, yeah.
Yeah, it was actually an email. STM, I don't know. Let's see, what is it? Okay. God, it's 2 miles long.
Yeah, that's why I was wondering.
It's one of those alphabet soup.
Yeah,
I wonder if they have a link online somewhere.
yeah, that would be more probably. If
Yeah.
they just had a registry. Okay, well, I guess we can all. Carl, did you put a comment in that he mentioned that there was an STM32 seminar?
I just added some. Yeah. And then I said,
Okay, there it is. So,
there's the link.
Okay, cool.
yeah.
And the link, if we test the link
Hopefully
works.
Good.
Yeah, nicely done. All right, cool.
Anyway. So I don't know. Is anybody interested in that one? It's, for one of ST's lower cost kind of 8-bit replacements, I don't know that it's not an H7 or something like that. So
I was watching online to see if it would come out, if anyone would put it out as an Arduino board or Nano board or something like that. But I haven't seen anyone essentially present something out for purchase yet. I haven't heard of any porting over to the Arduino IDE or.
Oh yeah. Those Arduino boards, they do have. It's kind of like a dual pinout. Let me see if I can find it.
Yeah, it has a Arduino shield in the middle.
Yeah, and it's I didn't go to present, but yeah, it's got kind of the Arduino pinout with its weird spacing, and then it's got all the other pins kind of on the outside of that. But yeah, and I guess there's been some interest. I think Dave Ackley's probably done the most, maybe with ST stuff. There was a guy that gave a seminar, showed up kind of sporadically at the club. Bald head. I can't think of his name. But
You think he's Dale Wheat?
Who?
Dale Wheat?
Dale Wheat. That's right. Yeah. Yeah, I haven't seen Dale in years. So anyway, he did some training stuff, I think, too. So
He's still around. In fact, I had lunch with him today.
Oh, you did? Okay. Yeah, he was doing something with hoverboards before COVID. He didn't really share that much about it, but he was talking to a guy, and they had, I think, 2 hoverboards. I don't know what he was doing with it, but
Right now, he's playing mostly with RISC-V parts.
oh, okay. Yep.
And he's discovered that they're almost an exact copy of the ST Micros, except with the RISC-V cores instead of a ARM core. But he's saying all the peripherals seem to be at the same addresses and they have the same bit patterns, etc.
Well, it takes a lot of work to create something original. If you can copy it from somebody else, no.
Yeah, well, Tom Lehrer had the right idea, right? Remember his song about let nothing evade your eyes but plagiarize? Remember his song?
Not really, but yep.
Lehrer was awesome.
So, that is curious. Yeah, you wonder how much of that goes on. Now at Dallas Semi, they caught some competitor copying chips. And I think the die was so close that, they had pretty good proof that it was a copy. But anyway, that was all I had.
Cool.
Thank you. Very nice update.
Next in line, we had Pat, and then Ted, and Mike.
So
Pat,
what's
what's going on
north
of us?
Way up in the Great White North, getting warmer. Things are melting.
Frosty.
Only about 6 or 8 more weeks of winter left. Last week, I was mentioning having trouble with these guys trying to get the pulse count to zero out as calculating a speed based on the dwell time between pulses. And a few of yous, I think it was Doug P. and David Ackley said, save yourself the headache and just get a motor with an encoder. And so there are the new motors with the encoders installed. Did some rewiring today on that. Started doing some testing. Got some fine tuning on my encoder routines. I think I've got my calculation wrong in my interrupt routine. So no matter which way I'm going, I'm counting positive on my encoder on both sides. Or one side's counting all negative, the other side's counting all positive on the left and right. So I'll work on that and fix that up. I managed to get at the front, and I don't know if you can see that, in here, there is a little, where the green light is, there's a little time of flight sensor, VL6180X. And I think they're good for about 100 or 150 millimeters. And so I'm using that to detect when the can is in the front of the robot. And that's what I was having an issue with tonight. And I was going to ask, I was getting a permission denied error on SM bus. But I managed to resolve the issue. I had to add my user to the I2C group to be able to use it. So as soon as I did that, I have the ability to do that. So I am able to get some readings back. I'm using software I2C on my Raspberry Pi to read it. So that's the other one. I don't know if you can see. Over here is where my I2C bus is, as opposed to the normal spot over at this edge, I believe, or right by the power connections. So I've used I2C bus 3, and it's using software I2C, so it allows it to do pulse stretching if required, clock pulse stretching, which is a problem with the hardware I2C. It won't allow it to do clock pulse stretching. So I just decided to jump the gun and go ahead and use that I2C bus 3 and on software. So far, everything seems to be going good. I have to wire up the power end of things. So right now I'm just powered up through a Raspberry Pi power supply. So I've got to get my battery installed. I have, it's possibly, I think it's out in the garage. I have a DC to DC converter to give me 5 volts for my Raspberry Pi. My motors will be run at battery voltage. So it's a step-down converter. It's a buck converter. And the motors will be run at a higher voltage and just controlled through pulse width modulation. So it's coming along. As soon as I get the hardware wiring and the things going, it's onto the software. A lot of my software is already written, just reusing some routines from other things. But there's a lot to write for a 6-can competition to be able to position a robot on the arena, find the location of the cans, find the location of the opposite goal.
In less than a minute and a half, too.
And less than a minute and a half, which is my target. So I'm sure Ray and I are after the same thing. So on top of that, I have to build an arena. So it's a little too far to commute to get there. So I will build and probably broadcast live from my living room.
Your encoder issues. You said one always reads positive, the other. Oh, so even if it's going backwards or forwards, it's always positive.
So one of them, when I turn the wheel, it's always, it doesn't matter which way I turn it, the count goes up. The other one doesn't matter which way I turn it, the count goes down. But at least I confirmed when I turn the wheel one turn, I'm getting 960 pulses. So I know that my quadrature signal is working coming in.
Yeah.
So I can double that as well, but I'm just using the 2 hardware interrupts on a Uno. So I didn't want to go to use some software interrupt. So I'm keeping just with the 2 hardware interrupts, one on each wheel.
Well, let me comment on that. If you take the exclusive OR of the 2 channels, when you get an interrupt, you can determine which direction it's going.
And you get what, 4x the count or 2x the count? I forget. 4x, right?
No. What I'm saying is, you get an interrupt on one channel.
Yeah.
You read both channels. You take the exclusive OR of the 2 channels.
Yeah.
It will tell you which direction you're going.
Okay, whether it's forward or backwards.
Exactly.
Okay.
I know people go through elaborate state tables and all that sort of crap. It's just simply the exclusive OR of the 2 channels. That will tell you exactly which way you're going.
I thought it also increased your count, though, of...
No, your count is strictly based on the number of interrupts you get.
Oh, okay.
Okay, so you on the Uno, you have 2 interrupt channels, and so you have one for one motor, one for the other motor. You read both the interrupt channel and the other channel.
Yes.
In other words, you take the exclusive OR. The exclusive OR will tell you whether it's a positive direction that you're going or a negative. That's all it takes. Now, in terms of the 2 different motors, you will obviously have to take the opposite sense because they're going different directions. But anyhow, that's it.
Right, if you switch if one is always going negative, you could switch your leads and it should go positive.
Yeah.
But one is reversed.
That too.
But that works only if you're only reading your interrupts on a positive pulse.
No, positive or negative.
So it'll work on either if you do a change.
Either edge.
Okay.
You take both edges. That is, you take an interrupt from both edges.
Yeah.
You take the exclusive OR.
Yeah, exclusive OR with the other bit.
And that's it.
Okay. That sounds much simpler than what I'm trying to do. So.
Yeah. If you go out on the web, they have all sorts of crappy stuff that's really complicated. Yeah. It's simply the exclusive OR. I see Ted nodding.
Yeah. That also would say too that even simpler. David is correct. Okay, there's no question about what. But if you're using an Uno, you can. There's a couple of ways you can get all 4 interrupts if you want to.
Yeah.
You can do that by using the pin change interrupts.
Pin change interrupt routine, yeah.
Yeah, that'll help. Okay. And another thing you can do is I'll put a link in. The guy that makes the Teensy has a encoder library. It's simple to use. You just stick it in your Arduino library thing, and I think you do. You create an instance, and then you just call it.
Yeah, and I've used that.
Very simple. Yeah, it's very simple. Yeah, it's great for Arduinos, and it's also great for Teensies. I don't know if it works with, say, just generic ARM chips, but for Teensies and Arduinos, it works great. I'll put the link in, and
Okay, great.
you can take a look at it. If you're only using 2 interrupts, there's going to be some speed limitations, but not probably going to impact you that much. I mean, not going to impact you. You know what I'm saying? But but something to look at. But David's right. So if you want to roll your own, that's the way to go. Let me find chat. I'll put that link in.
Okay, that was it for me. So I'll take a look at that library when you post it, and that's really good information, David. Thank you.
Okay, so I think I'm up.
Before we go on, if you don't mind, Doug made a comment about if you're only using 2 interrupts, you've got a speed issue.
Well, the more interrupts, in the ideal world, you would be using for 2 motors and two quadrature encoders. You'd want to use 4. One interrupt on each phase of each encoder. That would be the ideal situation. This library has, it has that instance, but it also allows you to use only 2. If you're going to roll your own and you're going to use an Arduino Uno, then you might want to roll your own, and you might want to use the pin chain interrupts to get interrupts on each transition. Okay.
Thanks.
But I probably, just for me, I probably use what I tend to do is I tend to use a mega board, so I have additional interrupts, and then I use the encoder library. But I have used the encoder library on Uno, but
Yeah.
Uno is too limited for. I think they also make a Mega in a very compact, square form factor. It's got all it doesn't look like an Arduino at all. It looks like a
double rows of pins.
Yeah, several rows of pins and stuff. But that's another way to incorporate it in at Mega. What is it, Ray?
2560.
Yeah, 2560. And so that's another possibility. But it sounds like you're way down the path on this one, so I don't want to, just add confusion.
The thing is that if you try to use any pin change, it's very intensive, because it takes a lot of code for it to figure out which pin it was that actually changed. And
actually, I kind of disagree with that one. I'd have to go look at some of my code, but I know it's not that hard, Dave. It can be that hard, but it doesn't have to be.
Well, it's not hard. It's just more intensive, okay? Because it will detect that a pin has changed, and then it has to decide which pin it was. Okay?
Yeah, right.
Okay. Well, that's more compute for a small chip. Okay.
Yeah.
So, yes, you do double the number of transitions by going to any pin and using both pins, assuming both the A channel and the B channel. Okay.
Mm-hmm.
But that only doubles it. You can use any change on either the A or the B, and that will give you, 2x.
Mm-hmm.
And you can go to 4x, two times as much,
Mm-hmm.
but it takes more horsepower. It takes more away from doing other stuff.
Yeah, but the Uno should be able to handle that. Yeah.
Well,
I haven't had issues there. But
I don't disagree with you that you can do it. Okay.
Mhm.
All I'm saying is that yes, it takes a little bit more, and you have a little bit less to do other things. So
Yeah. That's why Pat, you've probably seen that I'm a constant avoider of problems. And so, that's why I use a mega board, and I don't have to worry about, or actually now I'm really, really liking the teensies, but it works with a mega board too.
Can't disagree with you of stepping up the horsepower,
Yeah.
going to something else.
Yeah.
And
that's,
the Mega is one step up, Teensy's another step up, etc.
That's a big step, that teensy, but you don't need that. It's just I love the little board. It's surprisingly fun.
What's the clock rate of the teensy? Isn't it over 100 megahertz?
Well, it depends on which one you're using, but what's that link I get sent? Okay, it's www.pjrc.com. I obviously spelled it wrong when I said PCJRs. It's actually PJRC. Well, what's a few? What's dyslexics?
What's a few letter?
Yeah, what's a few little letters? Anyway, read it. You might, like I say, it's if you can use that, it'll just make it simpler for you.
Yeah, well, it's one of my concerns.
But if you really want to understand it, then you roll one yourself from, like David said.
You got to put that link in.
But I'm saying, if you just don't care, you're just saying, I just want my encoders to work, and I'm using this, then I would use this library.
Yeah. So the problem becomes that if I'm running 1 wheel revolution per second, I'm at 1 millisecond essentially interrupt time. 960 pulses in a second. On a 16 megahertz processor, it starts getting starting to get.
Well, what is that? Isn't a single instruction for microseconds? I mean,
yeah, it is.
So it's 16 meg clock.
Yeah. Well, so, I mean, you can get a lot done, is what I'm getting at.
Yeah. So that's what I'm just worried about is that, like you say, am I fighting a situation where I'm interrupting a lot of times? So you're trying to do serial communication, you're trying to do everything while interrupting for encoders.
Well, serial is going to be your biggest problem. You should try to do whatever you can to minimize that. And some of that could be first of all, you don't do any text. You don't send. You try to figure out how to have something that tells the other computer that this is what's coming, then your payload, and then your end of payload or your checksum.
Yeah, I'm using a serial transfer routine. Yeah. I've used it quite successfully. I'm sending 30 bytes of data. And so it's 14 integers actually, but it's 30 bytes worth of data, plus a preamble, like a start and an end. So for checking, confirming that everything got through.
Synchronization.
Yeah, I used to have my book here to tell you. If you look at the baud rate at 1115 to send, it takes a lot of time to send 30 bits. Oh God,
30 bytes.
30 bytes. Yeah.
At 115 kilobytes.
Yeah. Hold on a second. See if I can find.
Yeah, I thought the rule of thumb was if a byte is essentially 10 bits because you got a start bit, a stop bit,
I'll look
8 bits
for
of
it.
data. So divide your baud rate by 10, and that's what your byte rate is, I guess.
Yeah.
So
makes sense. Divided by 10, roughly, approximately.
Yeah.
Yeah, it's not real fast.
No.
Well, it's still. When you look at it, if I'm sending
30 bytes, you said
30 bytes.
Yeah. Yep.
30 bytes. 50 times a second.
This is one of the problems that when I first tried a LiDAR, and I was sending LiDAR information, with the serial across the serial port, and something like Uno just didn't have any time to do anything else. And it would slowly, what would happen is you'd see the buffer slowly fill up, and then eventually it would just spill over. Gosh, I wish I could find my
30 bytes at 150 or 115/200 is like 2.6 milliseconds. So
yeah.
Yeah, and it's 2.6
So,
milliseconds.
Times 50, you said.
Times 50.
So 100 milliseconds of your processor is being just sending serial data.
Yeah,
Yeah, that's
130.2.
as well as hardware. You're dumping it into a buffer, and the buffer is sending it out. So it's not taking CPU time once it's into the buffer.
It's true. Yep.
I haven't looked to see how big the buffer is.
Yeah, it's
so whether I have to buffer it in between sending, a byte at a time, or is it dump the whole thing in and off it goes?
You can increase the size of the buffer by changing the Arduino core. If you go out on the web, there's how to do that. And I'm trying to think. I can't remember the buffer size. I
thought it was either 64 or 256 bytes.
Yeah, that's what I remember. I think it's 64, and you can make. It's not hard to make it 256. You just have to ask for it.
Okay, it's just setting a register in memory, a CPU register to get the extra buffer.
I'm not sure, remember exactly, but the way you used to do it, Pat, and I'm sorry I'm so vague on this, but I haven't tried this in a long time, is that if you go into the Arduino environment, somewhere there's going to be what they call cores, which is like I'm on Arduino Uno, I'm on the Mega, I'm on the whatever. And in that, there's specification, and I believe the buffer is set there, if I remember right. So you just change that. It's kind of bad because you're essentially changing the definition of what a Uno is. Do you know what I'm trying to say?
Yeah.
And so there may be a way coming, because these are only Atmel chips. There might be, at Mega chips. You probably can just find the right place to change, like you said, a buffer or something and do it. But I don't know. It might be in the serial library too.
It looks like you can do it. I'm on the Arduino page. There's a serial begin, and looks like it's baud rate first and then buffer size second.
Okay. So they've changed it. Yeah, they didn't used to do that. Like too many people wanting it bigger, yes. What's they say the default is, Ray?
I don't see the default. Let me grab the thing here. Screen. Anyway. Bing. Yeah, right here. I don't know if you can see that.
Yeah.
Buffer size.
Okay, yeah, but that looks like he's increased it. I'm
right.
Curious
Yeah.
I think 60. I want to say 64 is the right.
That's what I'm finding online is 64 bytes.
Yeah.
Yeah, that's what I thought it was too. That's what comes to mind.
So anyway.
So I'm well within the 64 bytes I can dump everything into the buffer, and then it just spits it out in its own time.
Mm-hmm. Okay. Okay.
Yep.
So the other one, I like the Arduino Uno size basically for the shields. Everything plugs in. It's nice. It's the same footprint all the time. I know the Nucleo has the footprint built into it, but the board does extend outside of the physical size of the Uno.
Yeah, it also is a rough map. It's not, somebody has to translate the pin meanings to what the ARM chip is, and that's done usually in something like Platform IO or something like that, where you don't have to worry about it. But I wouldn't go with a Nucleo board, but I might consider one of these nano boards where they do two things. There's one type which is a 328. Otherwise, a standard Uno has a 328p.
Yep.
And then I want to say it's a 328PB, but I may be wrong, which I believe adds an additional serial port. Okay. Then there's another option, which is from a Chinese company, which I've mentioned before, where it allows you to double the clock speed. So where you're running it, and plus it does a lot of other cool things, but the main thing, but it does double the clock speed. So that's something you might want to, I'm not saying that if you're trying for May, don't screw with that shit. I mean, just roll along with what you got. But I'm just saying stuff you might want to know about for future robot,
I've been toying with STM Blue Pill, STM32 Blue Pill.
Yeah, Dave did a lot of work on that one.
Yeah, so taking one of those and just creating like a shield to drop one in that fits the Uno footprint, and be able to use something like that as a drop-in replacement, as long as your I/O is rated at a 3.3 volts.
Well, you might check. I swear I've seen that. Where it's a Uno, it's essentially an Uno format with a STM M0.
I have one, so I am playing around with that.
Yeah.
It's just I haven't done anything as far as going to. I haven't got any farther than that with it.
Okay.
So I've got a breadboard. I've been playing around with it. I've done some learning with some RTOS software on it, like trying to get the real-time operating system going, and as well as some other stuff I've been toying around playing with. What's nice about that is, how many interrupt pins do you want? They're all basically, you enable it. It's a hardware interrupt.
That's why the Teensy's that way too, and that's why I like the Teensy. One of the reasons I like the Teensy. The big problem with the Teensy is right now I don't think they're easy to get.
Nothing is easy to get.
Yeah.
So I bought a few of those Metro. It's a clone of the Adafruit Metro Express M0 Express, I believe. And so I've been playing around with those because while I could buy them, they were under $20. I bought, I think, 3 or 4. I'm starting to hoard boards because they're not getting any easier to get.
Yeah.
So that's where I was sort of looking at what to do. That one there, I really like. It's a good format. It's got the horsepower I would need. I just didn't want to, like you say, I didn't want to be changing right now because I got 2 months to competition. And, I need to be at this point, getting the wheels on the ground and rolling.
Yeah.
In terms of something that's easy to get, unfortunately, it's quite different, but it's the Raspberry Pi Pico. It's very easy to get these days and very powerful.
Dirt cheap too.
Yeah.
Yes, dirt cheap too.
So I had looked at those, and I do have a couple of them to play around with. Some of the smaller variants. So one Seed SEED or whatever puts out a variant, the Chow XIAO, and they put out a funny. It's a little 15-pin thing just to play around with. It's got a NeoPixel on it, and a couple other things.
And I have seen where people have used the PIO to create encoder routines.
Okay, that's what I was wondering about that little Pico. And those similar chips, are they capable enough to do encoder stuff, real-time stuff where you're capturing encoder pulses? And that I wasn't sure of.
Yeah, my understanding is yes. Again, I haven't done that, but you could go.
David has a thumbs up, so I'm assuming yes.
Yeah, I think you just Google 2040 encoder routines. And
Yeah, what I do, I find a lot on thumb wheels. You know, like a rotary volume control, that sort of thing.
Yeah.
And you know,
That's exactly the same thing.
it's the same thing, but a motor is spinning at a much, much higher rate.
Yeah, but those are running at, if you run them, basically they're running at 130 megahertz and quite powerful.
Okay. So that's how I was concerned whether, you know, with the MicroPython, whether it would be quick enough. MicroPython is a nice development environment. There's a lot of libraries out there now to work with it.
Yeah, I would say that MicroPython is probably going to be slower. Okay, it's actually four or more times slower, so that your 130 megahertz is more like, you know, 20 megahertz or so.
Oh, okay. So you're saying use the RP 2040 boards, but don't run MicroPython on them. Run C++, Arduino, or whatever.
Well, no. What I'm saying is that for the critical things, okay, like the encoders, run your C++.
Okay.
But for everything else, use the Python.
Yeah, like I said, I think there's actually done the ones I saw were actually running it in the PIO, which is a little different. Okay, it's sort of it's like machine language. And they only have
I haven't studied trying to do that, but yeah, if you can do it in the PIO, you can do the PIO from Python.
Okay, so you'd have on the extra, because typically they're dual core. So
well, no, the IO is actually a separate processor where you're actually talking about running up to what, 8 additional processors above the dual core.
Okay.
And so
independently too, I think.
Independently.
Yeah.
So
okay.
Is that if you can find a routine that uses the PIO stuff, the peripherals to do encoding, then you're home free, because you can code those up using Python and then use Python for everything else. That's what you're talking about, right, Doug?
Yeah.
I'm just looking up right now to see if I can find something on PIO for encoder examples.
Not CIO, PIO. P and Paul.
PIO program for quadrature encoders and absolute addresses.
It sounds like one. That might be one.
I'll throw that link in the, it's on MicroPython.
Yeah, another good one is the Adafruit QT Py. It's like 14 pins. It's got a quick connector on it, a NeoPixel, all the major interfaces, SPI, I2C. It's got a USB-C connector on it, and it's really pretty handy if you have any of the other quick stuff. You can string, like a B&O 055 with a display, and in 2 seconds you've got, you can do things very quickly and fairly high level kind of stuff with it. So, and it's pretty fast. It's a SAMD 21.
It's what's the processor?
It's the Adafruit QT Py. It's the SAMD 21.
Okay.
That's the same as on that Metro Zero M0 Express.
Yeah, I think
the
you're right. Yeah.
STM-V21 processor.
Yeah.
Okay, this
So-
is, all right, this is the standard, uh,
Plain Jane Pico.
plain Jane Pico. Okay, it's got 40 pins and, you know,
No
it's got,
Wi-Fi.
2 megs of flash in effect. And they, in the States, they, at like places like Micro Center, they're available every day for $4, or if you want the pins already on it, they cost $5. Okay.
Save a whole $1 if you solder your own pins.
So I'm gonna, if I ever make it to Texas, first place I'm gonna go is the Micro Center, because you know they're not available for $15 in Canada. You know, if you
You
can
don't have
find
to
them.
go to Texas for a Micro Center.
Yeah.
So November, I'll make a stop. Fill up my trailer full of Picos.
Okay.
Tell you what, email me your address and I'll see if I can send you some.
Oh, I'm good. Don't worry. I'll get them. They're becoming more available. It's just right now because everything is getting tougher to. Everything has been tough to get. Everybody wants more for it. In 6 months from now, they'll be available. I'm plenty good for what I got right now.
Well, I just went down because I wanted to have one that has the quote standard pins, because I wanted to plug it into something else that accepts standard pins.
Okay, yeah.
Spent $5 for it. I went down to find out how many they had. Their website says they have 125.
Help you and your team.
When I went down, they checked to find out, because they were having trouble finding them. Their system said that they had 120 of them. So the mic, these Picos are readily available.
Mm-hmm.
So one of the problems with the way things work in Canada, so I can order one and have it shipped. The problem is shipping is $13, let's say.
Yeah.
So now you got to group your order to be able to economize on your shipping.
Mm.
So
Okay.
that's what happens when you live in far away from wherever.
Yeah.
Everything.
Well, I'll tell you, the U.S. mail sucks too.
Yeah.
It's really gone downhill.
Yeah, I don't know if anybody saw that. There was a news program where they showed the blue boxes that, are all over the place, stuffed with letters, like coming out of the slot. It was so stuffed, and people stealing mail, and it was.
I've got to walk half a block to go get my mail at a community mailbox, so
Wow.
they're fairly secure. But if you get a package, if they can't fit it, and it won't, if all the big bins are occupied, they leave you a note, and you got to go to the post office to get it. Things like that. No more home delivery on anything.
Huh?
At least not through Canada Post.
Mm-hmm.
Oh well, so much for the mail system.
Yeah.
Who's next? I think I've monopolized enough time.
All right, I think I'm next if you're ready for me.
We're ready.
Aaron.
So I have been working on my outdoor robot. I've got it in a state where it's let's see. Just my camera.
Is this a gold star in the making?
Could be.
No. Let me get my camera here somewhere where it can see it. Oh bother. So it's just a
I
roller.
feel like I'm looking at a UFO video.
Yeah,
Yeah.
it's just a roller right now. I'm holding the camera because I couldn't get it to adjust. But you can see I've got okay, there we go. I've got it, so it's got really good suspension here. You can lift up any of the wheels and the others stay on the ground, so that's good.
So is your base rigid, Or does it flex a little too?
Well, right now my base is just a piece of plastic. You know, I haven't really got it all the way together how I want it yet. And that's the nice thing I like about the Go Builda stuff is with Go Builda, you know, everything kind of matches, so you can bolt stuff together. And then if you don't like it, you just change where it's bolted and just bolt other stuff on. So I think right now it doesn't have much ground clearance. Let's see, it's really hard to hold up because everything flops around. I have to do something to lock the pieces so they don't, you know, so it can only move so far, the suspension, because right now
Can you show us the bottom, Ted?
yeah. So the bottom looks just like the top. That's the bottom. And that's the top.
So all 6 wheels are driven?
Yes, all 6 wheels are driven. So these are, there's a belt tying these two together and one motor here. And then there's a motor on the front wheels here.
So it's 4 motors.
Yeah, 4 motors, 6 wheel drive.
Hey, that's cool.
Yeah. One thing I don't like is I've got this, I don't know if you get there, that kind of sticks out the bottom. So this is upside down, but this swivel sticks out the bottom. So I'm thinking of moving that to the top and then
offsetting the wheels. So you're going to offset the wheels, or how are you going to get it so all 4 of them touch
right,
the
I'll
ground?
offset the wheels. So and probably these linkages I'll move from the bottom here to the top side and then offset where they attach to the, you know, the suspension bars will offset where they attach.
54, 343.
I have a little more clearance on the bottom.
How big are the wheels?
The wheels, they were like 5.7 inches.
So the best you can
2.5. Yeah. A little under 3.
Yeah.
No, I'm sorry. They're more like 5 inches. I'm just measuring it right now.
Yeah.
So yeah,
clearance is the best you can do is probably around 2.5, right?
Yeah.
Have you given it the horse apple test yet?
No. So right now it's just a roller. All my wires are unplugged. I haven't even hooked the speed controller up. It was just the Saturday where I finally got everything bolted together. And my next step is to probably put some motor controllers and RC receiver so I can drive it around and see if it actually drives.
Cool. It looks good.
Thanks.
I'm real excited.
Yeah,
I like that idea you got there to keep them all 6 on the ground like that.
Yeah, that's a good idea. The thing I'd say is that by off-centering things, you could get, you know, more than a couple inches of clearance. Yes, the individual wheels might only be, you know, 2 inches, but in terms of the chassis to ground, you can get, you know, 4 or 5 inches by offsetting the pivot points.
Right. And that's kind of my idea. They'll still be, you know, where the wheel hubs connect to the wheels. There'll still be some clearance issues there, but being right next to the wheels, I think it's not as big a deal as having the whole chassis close to the ground. If I could raise the rest of the chassis, I think it'll help.
Yeah. Another thing that when I was watching the first teams, you know, that like Kareem's team, a lot of things they did, Ted, when they had wheels on a side, is they actually had the motor. So like, here's your chain drive, okay? Here's your chain drive. They would actually have the motor coming in at an angle and having beveled gears to run it.
Oh.
I mean, so that the motors weren't like this or even like this. They literally came I want to say they came in at an angle, but I don't know what type of gearing they were using. So I don't know.
One thing I was thinking of with these motors, if I could mount the motor up here instead of sticking out the back, if it went along and with the gear, that would help with a lot of issues I have with it right now. But first things first, I'm going to try it and see if it works as is. And
I mean, Ray did it with how big was your caster, Ray? I want to say 2-inch caster. So,
yeah, it wasn't very big.
So
maybe 3 inches. I don't know.
Yeah. So, I mean, you might have, if you have torque, you might be in good shape. As long as you don't get hung up on a bump somewhere,
Or a rut.
Yeah. Because there is, on the course, there is some ruts, that.
Or apples.
Yeah, well.
Yeah, I couldn't believe that. It's like, horse apples, what are they doing on the course?
Yeah. Anyway, that's cool. That's really cool.
Out of curiosity, how big are horse apples?
Well, the size of a size of a softball, basically, I think.
I was thinking like a billiard ball, maybe, or a little bigger than that.
They're bigger than that.
Bigger than a billiard ball.
Size of an orange, maybe? Big orange?
A small grapefruit, maybe? I don't know. They were about the size of a grapefruit. You know what I mean?
We don't have them around here.
They're Bodark seeds, I guess.
Seed pods, yeah.
Yeah, Bodark seed pods. So they're
it's a species of tree.
Yeah. Yeah, you can look at it. That would be a good Google. Bodark seed pods. They're, like I say, I want to say, to me, they look like the size of a softball. Or they can get that size at least.
Yep.
Yeah, I'd say a softball is probably a good analogy.
Yeah.
Mm-hmm. Yeah, that's what I like about the 3-phase brushless hub motors. The shaft, if you had to mount that on a plate, the shaft comes out of the center. It doesn't take away from your clearance that much.
Yeah, that's nice. No mounting issues there.
Yeah, but I don't know anybody that sells a DC hub motor though.
Oh, you haven't eBayed, huh?
Oh,
go to eBay. But all you have to have, Ray, is
it's a money option, huh?
Yeah, it's a money option. How much?
Yeah, I haven't done that.
Yeah.
So they're pretty pricey.
Bicycles.
Oh yeah.
You got plenty of clearance there.
Yeah.
DC motors.
Yeah.
Oh, on electric bicycles.
Mm-hmm.
Yeah.
Yeah.
They're hub motors. Yeah.
Yep.
Exactly. That's my point. So
Plenty
you got
of torque,
plenty of
too.
clearance there if you want it.
Yeah. It's an idea. I don't do the hub motors have like an encoder output or some sort of tachometer?
Well, if you have access to the 3-phase signal, I believe you essentially have an encoder.
Yeah, kind of a coarse tachometer. Yeah.
So, well, I mean, it's going to give you the number of revolutions, basically.
Yeah.
You can always put an encoder on it.
Yeah.
Yeah, I haven't got, if there's enough room on the inside, and it's kind of like an inside out motor, and I don't know if there's anything to attach to in there, if it's the whole thing is,
Yeah, you might end up using an optical encoder with a printed encoder wheel that you just stick on the side and just grab that.
Yeah.
And or even a 3D printed encoder pattern.
Like a disc. Yeah.
Yeah.
Or you can put some magnets around the wheel.
Yeah.
There you go.
Yeah, that's actually really good. And God, I think it was David that turned me on to these dinky. I mean, you want to kill your kid? buy these magnets. I mean, we're talking about the size of a pinhead type magnet. So you can buy them, since they're so small, you get a big chunk of them, and they're those super magnets. So you can make your own encoders there.
Yeah, you can buy them by the hundreds.
Yeah.
By the bucketfuls to make. They sell the little tiny ones to make, physical objects out of by sticking them together.
But like I say, you don't have any little kids around.
Yeah.
You know?
So I did that to one of I was building a go-kart that I wanted to put an encoder on the wheel. So I printed up a 3D printed disc with holes for the magnets. And then I put those little magnets in the holes all around this disc, mounted that to the wheel. And I used 2 Hall effect sensors that were offset, so it worked like a quadrature. One would read the next one. And it worked beautifully. So I think you could do the same thing, right?
Yeah.
Probably, yeah. Yeah, I haven't taken the wheel apart yet.
You might even be able. You might even be able to drill little tiny holes in the pattern on the hub.
Yeah.
Otherwise, just take 3D print you a template, stick it onto the hub, take your drill and just tap little holes around, and then stick your magnets in there.
Yeah. I know it looked like both manufacturers of the hoverboards, they do have a tachometer output, and it's kind of a weird looking signal. I don't know where and like I said, I haven't taken the wheel apart to find out how they do it, but it varies in amplitude depending on which phase is being driven. And the smallest it gets is like a half a volt, and it changes pulse width depending on the speed. So, you have to do like a pulse in statement or something in like the Arduino IDE to figure out, what that width is. And that's going to be proportional to the speed. So you can get it out of that, but it does require it's so small, down to a half a volt minimum. It's going to require like at least a comparator in there.
It might be worthwhile to look at the control board and see how they're processing that tach lead. What's it going into?
Yeah. Yeah.
Is it going straight into a microprocessor, or has it got some sort of comparator in front of it?
Yeah, I haven't mapped it out. And that was the other thing. I thought maybe the controllers would be, similar or identical. They're quite a bit different in their layout. But it was kind of curious that the motors seem identical.
Yeah.
So
has anyone played with trying to use the signals or the drive command from a brushless motor to get speed or encoder ticks? I mean, seems like it should be pretty accurate. There's how many poles around the motor each? So is there something inherently difficult or problematic with trying to use the brushless motor command as an encoder?
Oh, on the motor drivers that I have, I'm inputting a PWM, basically speed signal, and it does provide a signal that looks like I haven't figured out the logic yet. It looks like it's kind of an A not B, B not C, C not A kind of thing where you get 6 pulses out per revolution.
The thing is that your Hall encoders that are used to control the phases, you should be able to read those. And it probably has at least a dozen poles or more. So you should be able to get a pretty good reading by just using the Hall sensors.
Like the pulse width of the Hall, whatever width that is, to determine speed.
Well, either that or the counts.
Counts.
Yeah.
Just toggling the field back and forth. Those brushless, do they vary the frequency or the amplitude? I thought they varied the frequency.
Well,
I think you're right, Carl.
It's actually 3 sinusoids that, the faster those are, the faster the motor spins. But you can also control the torque.
They're exactly like a stepper motor. They're
Similar,
basically
yeah.
a stepper motor. They're basically a stepper motor. Okay. And so however many poles there are on it, and your Hall effect sensors tell you when it's switched from one pole to another. So you should be able to get, dozens of counts per revolution.
Yeah, out of the controller, it looks like I get 6 pulses per revolution. So
That doesn't sound right.
No,
Because you couldn't run the motor that slow and not have lots of poles.
yeah.
Well, I don't know about that, Dave. They might, this type of motor, the poles, there might not be a big count of poles.
Yeah,
like some of the little like RC ones might only have 3 poles in them. That's it,
Yeah.
So I don't know. He might have just 6 total poles. I can't hear you. You're muted, David. David, you're muted. David.
Can't hear you, Dave.
He's in a loop.
They're tens of thousands of RPM. Okay, the ones you're talking about that are for the rotors on the drones.
Yeah.
What I'm saying is that for a hoverboard, it's going slow. Okay, so it's got to have lots of poles.
Yeah, they usually have an odd number.
Have a sense from one of the Hall effects.
Well, like you say, it's easy to test. You just put a scope on one of the poles and just watch it. Rotate it one time.
Yeah, if I could show you my scope face, I'd do it, but that's hard to do for me.
Okay.
Well, I'm saying, that to run at the slower speeds, at the speed that you're talking about of a hoverboard, you're not talking about thousands of RPM. Okay.
Nope.
It's got to have lots of poles.
Yeah.
Right.
But
Yeah.
I'm sure it has the minimal amount that they can get away with.
Oh, I agree.
Or fit in the motor itself.
It's got to be dozens of poles. Okay, at least dozens. Okay.
Let's see.
And so
Yeah.
every pole has got to have a sense coming out of a Hall effect device. Because it's basically a stepper motor. Let's face it.
With an extra phase, maybe.
Stepper motors.
Well, yeah, in the sense that you can drive them with sine waves to get pretty accurate positioning and torque. I know the one small one, it definitely has just 3 poles, because it kind of clicks into like a magnetic detent.
Okay, so I'm reading here, and it says the pole count of a motor is the number of permanent magnet poles, north and south, on the rotor.
Yep.
There's always the same number of north and south poles on the rotor. For example, for a 12-pole motor, there are 6 north poles and 6 south poles. This motor would be considered a 6-pole pair motor. Okay, so it might not be that might be kind of typical. This is a motor maker. Let's see here. Direct drive frameless rotary motors. Let's go back.
Yeah, they say you can actually count the number of magnets on the rotor and figure that out. Yeah, I know this one. I can kind of feel the magnetic, where it's like detents
Yeah.
It,
Cogging.
prefers, cogging, prefers like a certain position in the rotation.
Mhm.
But that's probably the smallest one that I have that has an encoder and Hall effects. I've got and I think these may have been used in printers. I don't know. It was a Tanner special. The bigger one, I can't feel any detenting on it at all, so I'd have to take it apart to figure it out. But
Mhm.
there's just nothing there. And same thing with the hoverboard motors. There's no detenting on those either. But so I
Mhm.
guess it's a visual thing. Tear it apart and count the poles.
Yeah. Well, yeah. I'm trying to get.
Yeah, that larger motor will do well. Of course, with the setup that I have, I was like running it at 15 volts. It'll do about 2,500 RPMs. The hoverboard motor is a lot slower though at that same voltage.
Okay. Here I've Googled hover motor poles, and it says here hover board hub motors have 30 permanent magnet poles, thus 30 pole pairs.
Yeah, that makes sense. I mean, you really want it torque. You don't want super high speed on a hoverboard.
Well, yeah, that's what I'm saying is it's got to have a lot of poles because it's running at a low speed.
Right.
Okay? And so this is saying, a typical one has 15 pole pairs.
Wow.
Okay. And so if you're reading that out of the Hall effect devices, and instead of it being like our typical robot motors that it's got two sensors, it now has 3 sensors.
Yeah.
So if you get an interrupt on each one, positive and negative, you're talking about lots of counts per revolution.
Yep, I agree. If you've got 15 pole pairs, you're in good. That's way enough resolution.
That's what I'm saying.
Yeah.
And it's got to have that kind of number of poles to run at those kind of slow speeds and have any torque.
Yeah, I know that's the one signal that I got out for. It's out of the control board. It's not out of the motor itself. But it was just like I said, a logic combination of the 3 outputs from the Hall effects on it, and so it looked like 6 times that rate. I didn't figure out how many pulses I was getting per revolution of the motor.
Let me see if I can there. There's a motor right there. Okay. See how many poles it's got?
Oh yeah.
Yeah.
Okay. That's what we're talking about.
Oh yeah.
Okay. That's what's inside your motor. Sorry, it's not more clear, but anyhow.
Yeah.
That's what
I'm sure that's probably what the inside of the other one looks like.
Okay. So that's what's inside these motors. Lots of poles. Lots of poles. So that looks like, it would probably be, 15 pole pairs or so. Anyhow.
Yeah. Even if it was 30 transitions. Yeah, it's probably doable for velocity. Positioning. Okay, say I got for 1 revolution 360. Say I got 30 transitions. That's 12 degrees per position. It's not bad resolution, but 12 degrees is, you may want it down to a degree if you're going to do positioning.
Yeah, but that's still every few inches.
Yeah, depending on whatever the outside diameter of the wheel is.
Yeah, well, I'm just
Yeah.
saying it's still every few inches. So I mean, it's not really great,
Right.
but it'll still get you in the ballpark of where you are.
Mm. Yep. Maybe for an outdoor competition. I don't know.
Oh, yeah.
I would not even suggest it for indoor, but I'm saying for
Yeah.
outdoor.
Yeah,
Hey,
it's too much power.
Yep.
Yeah.
Maybe I could rely on the compass for that anyway. So as far as the actual orientation of the two or something. That's what I did on the other one.
yeah, I'd say for orientation, you don't want to use odometry anyway, but for distance odometry, you should be able to do pretty good. And use compass or something else, not or gyro or whatever for angle.
Angle, yeah. Well, that's what I did on the last one. Worked out pretty good.
I've tried using odometry for direction on an outdoor robot, and it's really hard because any skidding or sliding, it's off.
Yeah, you go over a clump of grass and
Yep.
one side, not on the other, and one wheel's
Yeah,
traveled a little
For
further.
angle, it really sucks. For distance, it's reasonable, but for angle, it's irrelevant.
Pretty much, yeah. Yeah, the B&O 055s work pretty good for that outdoors. So
I think Mike's next, right?
I
I
had
had Mike next, then Doug, if Green came on.
doesn't look good for that.
I'll go anyway. It looks like he's not going to come on.
Well,
I think Mike was next, Doug.
No, I understand.
Oh, okay.
Yeah,
Yeah,
Mike, you're up, then
Doug,
Doug,
then me, then
open
open
Mike.
Mike.
Okay, cool.
Yeah, well, I was listening into the motor stuff. I really don't know motors, so glad to hear that you guys know them. So hopefully someday I'm going to get in that direction. And I was just basically, I like the Raspberry Pi Pico. I've used it before, and programming the PIO is really fun. Little micro-coded engine. But I was going to show a demo of my 6-can.
Cool. Let's see it, Mike.
So should we get our stopwatches out, Mike? You think you're competitive?
No. Don't time it. No.
Yeah.
And okay, so I need to present a window. There we
Ooh,
go.
Harold, you have a cool blinking thing behind you.
Yeah, it's not exactly a blinky thing. It's actually a plasma light with a D20 instead of a dice flattened out, and what you're seeing is the arcs going between all the stuff. I can get out of the way here. Hold on.
Well, let's let Mike do his presentation.
We'll put
Put
you in
you, Harold.
Yeah, sorry for hijacking that.
So basically, using the mechanism wheels and and the ultrasonic sensors. And right now, I'm not using any other sensors on my processor. And the USB cable is basically for debugging and stuff. I plan to cut the cord and put use the BLE, the Bluetooth, sometime in the future. And so it's basically, okay, go back to where it started, and okay, is there another can? So it goes and finds the other can. Does a little overshoot. And
Nice.
I figured it's functional.
Yeah. Okay, Mike, gold star.
Yeah.
Way to
Way to
go.
go.
Yeah. And how do I stop presenting? So this is, so remember, this is my little robot here. It's about 7 inches square. On the other side is a large battery. Basically, it's all using all the parts from another project, which is a Spider, but I added the mechanism wheels to it, and of course rebuilt all the structures. And on the very front is the Arduino BLE Sense, and I'm using the 9 degree IMU in it to keep it going in a straight line. At least it knows it's not changing. And since it's a mechanism wheel, I don't have to rotate the thing. and in here, hard to see, but there's a servo controller that's used for all of my servos. So my wheels, I just took an old servo, a 90G, and turned it into a 360 rotation, so I could use my servo controller. And I'm using 2 servos for the gripper because I have a lot of servos. And
Do you have any?
Servo for each of the sensors.
Do you have any encoders for those servos or feedback?
No.
Okay.
So what I'm doing is one thing I got to work on is the accuracy of this thing, and I just measure distance by number of milliseconds or seconds that the wheels are turning. But I'm realizing that it's really sensitive to the battery voltage. And
right.
As I keep going, I keep trying to calibrate it, and the number keeps changing. So
what I've seen people do is hook up a voltage sensor to the battery, so then they can calibrate it that way.
Right. So I need to get a voltage sensor.
Yeah.
And I've seen some nice ones that are voltage and current, so I know how much current's going into it. And the current would be nice to know the center point of the 360-degree servos, like when it's in a stop position, because there's friction in there, and I'd like to know right where the exact center is. And if I could just read this current sensor, I could figure out, okay, now I'm centered. And so the forward and reverse, we probably have to be more balanced. Right now, I have a little offset. And so each of my wheels has a PI loop, which is using the IMU to keep it straight. And so it basically adds different values to each of the wheels to keep it heading in the straight direction. And like for forward, reverse, left, and right, they all have their separate PI loop, or actually separate integrators. And because they all have the different wheel inaccuracies and different friction. So basically I'm just building it with what parts I had left over from an old project. And the only thing I've bought so far is one HC04 sensor.
Cool.
So
Very
my thing
cool.
is I want to go to the competition and function and be there. And the whole idea is like I built it from nothing. So yeah, that's going to be my project. Is okay. That's what I'm trying to do.
In short
order, it's looking good.
Yep.
Yeah. So from now on, the videos won't be so interesting because they'll be the same as this one, but just a little better.
Yeah.
It'll be a lot of fine tuning and tweaking.
Yeah. And different, you'll start doing different can combinations too, so that you'll find all the bugs, you know.
Oh yeah. If the can is close to the wall, the ultra sensors don't like it. So I'm working on. I'm trying to come up with a strategy. I think the strategy is to move the robot close to the wall before it tries to sense the can. Otherwise, it's reflecting off the wall and it just disturbs the sensor and it just sort of goes. So doesn't. Sometimes it says there's no can there. Yes, there is. Maybe next year I'll put a camera on it and put a Raspberry Pi and stuff. This is fun.
Sounds like it's going really good. I really, yeah, it's pretty impressive, Mike. Nice.
So no one has come out with a servo that has like an encoder in it. You'd think that'd be a.
I believe you can buy them, but they're pricey.
Yeah, there's
Dynamixel has them.
Yeah.
Who?
The other one, Dynamixel has a servo that you can do just about anything with. Continuous rotation, any number of degrees, including more than 360 degrees if you want to turn it, or go straight for so far. And then they show position, position all the time of what it is.
Yeah.
Mm-hmm.
Yeah.
But the other one I've seen people do with just a regular servo is bring the wiper position, a fourth wire out of the servo, the wiper position. And then you can look at that with your analog port, and you can determine what position your servo is actually in.
That's good.
Yeah.
But
Will Canute used to do that, Pat.
That could be quite noisy, I believe, as well when you're using the wiper.
Yeah, because I believe it can be.
So I was looking at this and going, okay, I could put better sensors on it. I could put better motors on it. But I think I just get small incremental improvements. So I decided I'm not going to spend the money. I'm just going to try to get what I have working the best it can. So
it's looking good. It's just IMU feedback on otherwise. Yeah. Goes to show what a loop can do to take out all the errors, right?
Yeah, there's a lot of errors in here.
Yeah.
Mike, we really need you to kick Scott's ass, though. That's the whole goal here. So
next year, maybe. Yeah.
Yeah. Based on what I see, I'm going to have to withdraw my name from the competition in the spring. He's already got me beat.
No, don't give up.
Never give up.
So I'm just trying to get. I'm trying to get the gold star for the cheapest implementation. That gets the job done.
There you go.
Yeah.
The fastest word for the fastest from scratch. Well, cool. Well, nice work. Look forward to watching that move along. I think next in line was Doug, and then me, and then over to Mike. Doug.
Okay, let me share here. Got a couple of things that I wanted to share. First one would be this. Pololu, which has sponsored our club in the past, has come out with an early adopters release of their 2040 little round robot. Yeah. So something they had one in the past, but they used this 32U4, which is basically like an Arduino class processor. Now they've gone to a 2040. And if you read this up here, they're giving some discount prices right now. So if this is of any interest to you, this might be a good time to buy it. Though it sounds like they're actually building them to order, and they're, it's not clear if they have any real example hardware finalized. They really want it for people who have some experience, but thought people might be interested in that. Okay, the second thing, I'm going to jump around here because I've got one big one that I wanted to show in the end.
That looks kind of interesting because it is the Pico board they're using.
Yes.
Yep. It's got a better OLED display too. That other one was.
Yeah, the other one had a 2x. I don't think it was
8. I think.
Yeah, something. More than that. POLOLU. That it looks like 10. Might have been a 2x10.
Yeah, it was pretty bad though. Pretty low res.
Yeah. The next thing for people who might is this link, and I'll put that in the chat. This is by Element 14, and it's a exploring software defined radio. It's soft. You use a module that basically performs the radio transmitter part, and you use the Raspberry Pi to set frequencies and do a lot of other stuff. So let me see, where's the link for this guy? Let me quickly put that link in here.
So were those for telemetry primarily, or?
Well, I tell you where I used it. I picked up an old weather station, one of these $100 weather stations, which is on 430 megahertz. And I put in the software or the Raspberry Pi, and it interpreted the commands and everything. And so even though I didn't have the part that goes inside of the house, I was able to read it. So that was pretty good.
Does the Raspberry Pi do signal processing, or is that all done in somewhere else?
Yes, I think so. There's another piece to this besides the Raspberry Pi, and I don't know exactly where the boundaries of those two are. Okay.
Some transceiver chip then, or something?
Yeah, I want to say that it is that, but it in itself it's not really a radio. And then here's another white paper that came out that I thought some people might find worth looking at. It's free. So this one is the 2022 robot.
Looks like you could program it to give you an appendectomy or something there. I don't know.
Anyway, here's another one that I thought people might like. Okay. Now, let's see, I got that one out. Okay, so now I'm coming to the one that I really wanted to talk about. This is RS SparkFun Mechanical. They've changed their model. So they have the Explorer, which we all love and know, probably already have it downloaded on your program. And then they've created two additional levels. They got one called the Creator and one called the Engineer. The Creator basically fleshes out with Design Spark Mechanical. The Engineer level fleshes out Design Spark Mechanical and Design Spark PCB. All right, now this is what, so here's what you get normally when you download Design Spark. You get unlimited, that's PCB. I don't do PCB on this. Unlimited projects, you get different tools. You can generate a bill of goods. You can import PCBs in the IDF, which if you're not using their PCB board, I'm not sure. I don't know how universal this format is. Has some other things that are cool. But when you go to the next level, it allows you to reverse engineer a solid model that's been scanned in. What that means is you can take an STL model and turn it into a step model. Okay. And it has some mirroring, some additional things. Here's another one that's big. It allows you to import and export step, IGES, and AutoCAD, DWG, and DXF formats. So that's a big improvement. And I think that's about all you get. But here's where what's there. You can download it right now and sign up for it. And until the 31st of March, it's free. Allows you to play with the program. And if you wanted to continue, and I'll be quite honest, I may continue this myself. I'm not sure. I mean, that's $12 is $120 a year. So, not to have to jump.
Is that pre-inflation prices? Should we add a 0 to the end of those? Or
No, I don't know what this is what they're starting out with for sure. All right. So I wanted to show you this. Okay. So here I've taken, this is you can see this is a servo mount on a plate that I use. What is this called? Okay. This is actually an OD light servo mount. Okay. So the servo goes here and this is the thing. And you can see it's all got facets, right? Typical STL format, you know, everything is faceted. So you can click on one of those, do this, and you can convert to a solid. And now the only places that are segmented is, you know, the holes. So how you would do that is, you know, you'd click on this and you would say plain view, and you probably go, oh, come on now. Plain view, why did it do that? And then you would just draw a circle in the middle and re-drill the hole basically. So you can get rid of that segmented pretty easily. You can do a file, save as, and now you have all those other options on here. So you can save it as a step file, which is a pretty good universal file to be able to use in other programs. Now, is this functionality to take it from this to that? We've always been able to do a trick on importing to get step files into mechanical design mechanical, but we know, you know, to get it out has always been an issue. There were two ways. One where you could hack into one of their DDLs and you could extract it as a space claim file, but that's pretty complicated and not something that I generally do. I've done it. Another issue you can you can import this into FreeCAD, and you know, you could then do basically what I just did, okay? But you have to go through several steps, and sometimes it breaks. So I'm just saying is this puts it all in one program, makes it very easy to do, and like I say, I like it. And
Sounds interesting.
yeah, it does, doesn't it? So anyway, I throw that out as a possibility. Now at this level, you can see you get a few things on Design Spark PCB, but I would prefer, let's see, there was something big here. Oh, one of the things that Design Spark PCB can't do is hierarchical schematic designs. What that means is a hierarchical design is where you can take signals and define them and then have them on a second page what that module does of your circuit. And KiCad or KiCad, depending on how you want to say it, can do that already. And I'm not really sold on this product. I'm more sold, but I am sold on Design Spark. And this gives you all of the tools that they're going to give you for any reasonable price. So anyway, I'm going to try it until the 31st and find out whether or not I like it enough to buy it. So I thought I would just share that with you so that if you wanted to try it, you could download it and take a look at it. Let's see, I think that's it. Olu subscription price. If you want to see somebody else do this, this is a link, YouTube link. of how to change. This is where I got the how to change STL to step. Okay. All right.
That sounds very interesting.
Yeah. Anyway, I just thought I'd share that with you because I thought I was pretty interested in it, and it's not going to break the bank, and it could be, if it's left, if there's no discounts for a year, if it's always charged by the month, then there's no reason for you to like drop in and out. Let's say you got a project, drop in, do it for a month, drop out. It would definitely be worth $12 if you're actively using it for a project. Anyway, some thoughts.
So you're saying that you can do it on a discontinuous monthly basis?
I don't know. I'm assuming since they did not issue a yearly price, David, it suggests that you could probably drop the subscription,
Yep.
and then
Pick
pick it up again. I mean, that's what it would seem like.
Yeah. Since I'm only occasionally hacking into that, that sounds very attractive.
Yeah, and otherwise it gives it the functionality that, like I say, it's not that you couldn't work a tool chain around that. I mean, Fusion 360, even if you wanted to use Design Spark Mechanical, but you had a Fusion 360, Fusion 60 has some powerful tools that'll do some of that. You know what I mean? So, but like I say, I try to do things simple. I'm only trying to learn one of these things, and this is the one I chose. So,
I like Design Spark.
Yeah, it thinks the way I do. That's what I really like about it.
Yeah.
And there's a 360 is a very powerful program, and a young man like the gentleman that was here a few weeks ago, I would strongly say that's a more portable skill, but I just don't think that way. I mean, the way they do things is kind of weird. So,
well, it's a sort of thing that a more powerful tool tends to be more complex to use. And like you say, Design Spark, it fits just the way I like to do with things.
Yeah. Okay, so I think that's it, Carl. It's your turn.
Okay. Looks like I'm up, and then I think Harold is interested, if I heard right.
Yeah.
At least we're interested in what Harold's got, but I got two things. The first is an interesting, it's more IoT than it is roboty, but it showed up in the feed somewhere today. Some little device. They claim that it's energy harvesting, but I think what they really mean is that they must be doing something good with power management, and something unique with the way they have tiny super caps on this module. Because it claims to have a Cortex M4 and a BLE compatible radio, so that and a handful of I/O. But they claim that the way they've got this thing assembled, you just give it a solar panel. It's 23 by 8 millimeters, and you can get 25 milliwatt hours of overcast day, which is about the same amount of power you drain from the CR 2032 if it lasts a month.
Mm-hmm.
So anyhow, you still have to get it, I think, into pretty careful coding to miserly coding at that to do anything with it. But it looked interesting. So for anyone interested, I thought I'd share it along.
Mm-hmm. Got to be mostly sleeping, right, for that power level?
Oh, it has to be. It has to be. Yeah.
Yeah, you wonder why they're using an M4 and why they're not using one of the low leakage low power units from STM.
Yeah.
One of their
It's a
STML 32s.
Yeah, that's like a third of an inch and less than an inch for the solar panel. It's not very big.
No.
Yeah.
Did they say how many cells, Carl, on the solar panel?
No, it's very
Or
short.
is it just that small? It might just be one cell. That's what I'm thinking. That would be a half a volt.
Yeah. I didn't read too deeply, but yeah. So however miserly it is, it's pretty miserly.
Yeah.
Okay,
then
for
for my second
Yeah,
one,
but if you look at the some of these calculator solar cells, they put a lot of cells in a very small area.
Yeah, that's what I'm saying. You just have to know how many cells. But since in that case, though, David, they're giving up, power to raise voltage. So
Yeah, I agree. I mean, you trade one for the other. It's the total area. There you go.
Maybe they meant centimeters instead of millimeters. That would power it.
Yeah.
One time I tried to harvest solar cells off a calculator and found out they were fake.
Yeah.
It was battery powered.
Yeah.
Oh, that's funny.
Who
Who knew?
Yeah.
Till the TED teardown. Okay.
I
I
have
have one other
kind of brief thing.